Hello, we are back and ready for section 1.4. We're going to dive deeper into equations of lines, or linear equations as we call those. And then also as we get through the section, we're going to talk some about modeling with lines. So one definition I wanted to throw out here before we dive into the notes, and hopefully you are printing these notes out so that you can add to them and fill in the blanks and work the problems. Up here I just wrote equivalent equations have the same solutions. So the reason I did that is we're going to be talking about different forms of the equation for a line. So you can write the equation of a line more than one way. For example, if you know that an equation is of a line, you could add something to both sides. You could multiply both sides by the same number. You could take divide both sides by 2 or whatever. There's certain things that you can do to an equation and it still has the same solutions, which means if it's a linear equation, the solutions are going to fall on that same line. So as we talk about slope-intercept equations and point-slope equations, which is here at the top of this first page of notes, we are not talking about different lines. We're talking about having two different ways to write the equation for the same line. Hopefully that kind of helps this click for you a little bit as we go through it. So let's just dive in here and talk just a little bit more about the slope-intercept equation. We introduced this in the last section. We said that an equation is linear if you can write it in the form y equals mx plus b. We're going to now formally call that the slope-intercept form of a linear equation. So basically, if you're given an equation and you solve it for y, and when you solve it for y, on the right-hand side, you end up with two terms. One of them has an x and the other one is a constant. You know it's a linear equation. You know that if you plot all of the x, y's, ordered pairs that make it true, they're going to fall in a line. Okay, so this very first problem, you're asked to find the slope-intercept equation. So your answer is going to be y equals, and then a number times x plus another number. That m and the x, the m and the b will be filled in. That fits a couple of things here. First of all, it has a slope of -3/5, and it passes through the point -5, -1. So that means -5, -1 is a solution, or it's a point that is on this line. So to solve this, we can start out with, we know the slope, so we can plug that in. So we know that this equation in the end is going to look like this. Y equals -3/2, or 3/5, I'm sorry, I read that incorrectly, -3/5 x plus b. But we don't know what the b is. The b is going to be a number. We're not done until we've replaced both the m and the b with numbers. But we know one of the solutions. And what does the solution mean? What's the definition? If I replace x and y with -5 and -1, it has to be true. So I'm going to go ahead and replace the x and the y with those two numbers. And then the only thing left in that equation that is not a number is the b, and we can solve for that. So just rewriting this, replacing the y with -1. So -1 equals -3/5 times x, and I'm replacing that with -5 plus b. I now have an equation. If I solve that for b, I know what b is, and I'm almost there. So -1 equals, I put the 5 over 1. I have negative times negative, so those negatives are going to cancel out. The 5's cancel out, and I get 3 plus b. To solve that, I need to subtract 3 from every side, from both sides, and I get b equals -4. So I found b, but the question said to write the slope-intercept equation, so I go back here to my y equals, and I fill in the b. Y equals -3/5 minus 4. That's what we're looking for. We're looking for the slope-intercept form of this equation, which is right there. Okay, let's go down. There is another form that is very useful, and it's called the point-slope form. And it's actually very useful when you're given a problem like the one we just did, because we're able to plug that in a little bit quicker and get to our answer. And I really think some people are going to prefer to do it the way we just did it. And some people are going to prefer to use this form of the equation. Notice B isn't in here. B is embedded in here in this equation, but you don't have to solve for it to get the answer. So we're going to do a problem that is just like the one we just did, except different numbers. So we're writing the slope-intercept form of the equation where we're given the slope, so we're given the m, and we're given a point, our x and y, that makes this true. So with this form of the equation, you can plug the m in, and then plug in the point that you're given as x sub 1 and y sub 1 into this formula. And again, this is called the point slope equation. So know that name. You know that because you have a point, x1, y1, and slope. That's where the name comes from. Just like up here, the name comes from having the slope and the y-intercept. That's why it's called slope-intercept form. So plugging this in, I get y minus y1 is -5, so that makes it a +5, equals m is 2/3, and then x minus x sub 1 is -4, so subtracting that makes it a +4. And now I'm going to do a little bit of algebra here, and we can distribute the 2/3, so we get y plus 5 equals 2/3 x. I hate dealing with fractions, so something I like to do, so that's going to be 8/3, is just multiply everything times 3, and that's going to make those fractions disappear. So then I get 3y. Actually, I'm not going to do that in this case. Let me back up. Remember our goal, I forgot kind of where we were headed. Our goal is to get this into slope-intercept form, so I want it to be y equals mx plus b. The only thing I need to do here is subtract the 5, and I know my handwriting isn't very good here because I'm writing with the mouse. So I'm going to subtract 5 from both sides, and I get y equals, and even though this doesn't look like it, this is 2/3 x. That's my mx. Plus b, I have 8/3 minus 5. 5 is the same as 15/3, so I have 8 minus 15 over 3. And that is a -7, so I'm just going to write this as -7/3. And there we go. That is it. So we didn't have to plug in and solve for b before we could get to our answer. We were just able to plug in the slope and the point and get there. One more problem before we move on. In this problem, we're not given the slope. We're just given 2 points. So we want the slope-intercept equation. So our answer still has to be in the form of y equals mx plus b, but we're given 2 points. Well, what do? What were we given in these other two problems that we're not given here? We were given the slope. But we know the formula for a slope is to subtract the y's on top of our 2 points and subtract the x's on the bottom. So on the top, I'm going to take 7 minus -5. So that's the same as 7 plus 5, or 12. In the denominator, -3. And notice I'm keeping that same order. I did the first point minus the second point when I did the y, so you have to do the same thing with the x's. If you did it the other way, make sure you're consistent. -3 minus -1 is -3 plus 1, which would be -2. So I end up with, reducing that, 12 divided by 2 is 6, and it's a positive divided by a negative, so it's -6. So I'm going to use the point slope form, which is right here, and I can pick either point. So if there's one that you like, pick that. I'm going to just use the first one and say y minus 7, that's my y for my first point, equals -6 times x minus -3, or x plus 3. And I can distribute the -6 and get -6x minus 18. And then I need to add 7 to both sides. And I get y equals -6x minus 18 plus 7 is -11. And we're done. So this is a very handy formula to know. And just realize oftentimes you're going to have to put your answer in the form of y equals mx plus b, which is slope-intercept. So know that one, and also know this one. Okay, I'm going to end this video here, and I will jump back on to cover the next section, which is on parallel lines, in the next video.